Welcome back to Trial by Wire. My name is Denton, and this is our first official episode. I am really excited to dive into a bunch of different technology topics with you and dig into the fun, ethical swamp that software engineers like me navigate daily, whether we know it or not. However, before we can get there, we need to give ourselves a good foundation. Like I said in episode 0, I'm not expecting you to have any background with technology coming into this. We are going to start with the bare basics and work our way up from there. If you're already a tech whiz, you may feel inclined to skip this episode, but I would encourage you to stick around just in case. Just like the word charge means two different things to a cashier and someone who makes batteries, you may have a different understanding of these terms than me. If you need extra incentive, though, you should listen in to critique my definitions and tell me where I've gotten it wrong. I'll drop my contact information at the end of this episode. The obvious one may be sitting at your desk, a so-called desktop computer. These are composed of a monitor, or the screen that you look at, the computer itself, or the big box that sits under the monitor, and any peripheral devices, like a mouse, which is the device that moves the pointer on your screen, and the keyboard, the keys that you use to type text on the screen. If your computer is just a monitor and doesn't have a big box attached to it at all, you probably have what's called an all-in-one computer. In this case, the computer, the box, is baked into the monitor. You may not have a desktop computer at all, since laptop computers have become so much more popular over the last decade or so. In a laptop computer, the monitor, the mouse, and the keyboard are fused together in one box. Laptop computers are much slimmer and easier to carry around, and you could still plug in monitors or other devices if you want to set it on a desk. If you have a MacBook or a Chromebook, for example, those are both laptop computers. Next is the computer you're probably most familiar with, handheld computers. Your smartphone, if you have one, may not seem like a computer, but it has all the components of a desktop computer. The monitor is your phone screen, the keyboard comes up on screen whenever you need to type something, the mouse is your finger tapping and swiping, and the computer portion is the chip and other infrastructure that's all hidden right here behind the screen. Tablets are the same, just a little bigger. These can include things like iPads, Surfaces, Galaxy Tabs, your kids' learning tablets, and any other rectangles with screens that you hold. Now, let's get to some of the less obvious examples. Any kind of gaming console, whether it's PlayStation, Xbox, Nintendo, or anything else, is a computer. We've swapped the keyboard and a mouse for a controller, and the screen for a TV screen, but the elements are still there. Wearable devices like Fitbits, your favorite brand of smartwatch, and virtual reality headsets are also computers. You may have a smart home device like a smart speaker, a smart doorbell, a smart TV, a smart fridge, any other kind of smart device. If it's smart, it's probably a computer. Some of these even replace taps and swipes with voice commands, but you're still interacting with a computer like you would using a keyboard and a mouse. But what about your non-smart devices? Microwaves are examples of what are called embedded systems. Michael Barr, a software consultant and former adjunct professor, defines an embedded system as a combination of computer hardware and software, and perhaps additional parts, either mechanical or electronic, designed to perform a dedicated function. That's some technical mumbo-jumbo for a computer that's made to do one thing and do it well, like heating up your leftovers. Laptops can do a bunch of different things. Browse the internet, send emails, take notes, stream videos, and so on. Embedded systems can't do all of those things, so they may not look like computers, but they are. Embedded systems are in lots of different electronic objects. Automated pet feeders, coffee machines, your car's brakes, timed lights, smoke detectors, toys, and so on. Even your computer's mouse is its own embedded system. While not everything that uses electricity in your household is an embedded system, lamps, for example, are just circuits with manual switches. Quite a few of those devices are. Finally, let's talk about the computers that aren't in your home. You can see examples of desktops, laptops, wearables, embedded systems, and other computers at your work, in the park, at the store, at your place of worship if you have one, and so on. But you use many, many more computers than you know every day just by logging into the internet. That's because the internet is a network of computers. To understand this, think about a nice restaurant. You walk in, you're seated, and you talk to the waiter to order food. In this case, you're what's called a client of the restaurant. Although you only ever talk to the server, the restaurant employs a number of people to keep the restaurant running. Your kitchen staff, your cleaning staff, your managers, your hosts and hostesses, and so on. In the same way, when you access a website, your computer, the client, talks to a kind of computer known as a server. Servers are not designed to be used by an individual person like laptops. Instead, they supply websites and web content to thousands and thousands of users. Like the workers of the restaurant, servers do different things. Some take requests from users, some process data, some store data, some enforce security, and so on. Unlike embedded systems, though, servers can do a whole bunch of things at once. Some of them run entire websites by themselves. Although, like restaurants, the bigger and more popular your website is, the more and better servers you need. Big websites like Facebook and Google have countless numbers of servers. A big takeaway here is that your daily life probably involves hundreds, if not thousands, of computers a day. Computers are around us all the time, so it's important to be aware of that. That way, we can start to understand how they affect us, and conversely, how we can affect them. All right, so far we've only talked about the different types of computers, but not about the computer itself. Let's dive a bit into how computers work. First, let's talk about the difference between hardware and software. Hardware is the physical makeup of a computer, what you can touch and feel. We've already talked about the different parts of a typical computer: the computer itself, the monitor, the keyboard, and the mouse. However, within the computer are different components that help it function, like the hard drive, or the motherboard, the wiring, the inputs for devices like USB drives, and so on. It's easy to forget about these parts because engineers have figured out over time how to make these pieces smaller and smaller. So small that they can be crammed into the palm of your hand. We won't dive into the details of these components right now, but I want to point them out to separate them from what comes next. The software, on the other hand, is the portion of the computer that you can't touch. Software is what makes computers come alive. Without software, a computer is a very expensive rock that doesn't do much. Software is all of the ones and zeros that tell the hardware what to do so that the computer is usable. The base software on which most other software is written is called the operating system, or the OS. You're probably familiar with Windows and Mac OS. These are both popular operating systems written to run on laptop and desktop computers. Most operating systems provide a couple things to users. For example, a desktop view, a way to store your files, some system utilities, and a way to set your settings. Think of an operating system like an unfurnished house. It's usable, sure, but you can't sleep or eat there with just the basics. The things that make it livable have to be added later. Those are called applications. A software application is a piece of software designed to do something. On a mobile phone, these are usually referred to as apps that you can download from an app store, such as the Google Play Store or the App Store if you're on an iPhone. Every square on your computer's home screen opens up one of these apps. You may have noticed that some applications only install on certain operating systems. For example, it might be Windows specific, or it might only come as a mobile app and not as a desktop application. That's because applications run on top of operating systems, so the application has to know how to talk to the operating system. For example, if your house is in the US, any lamps from Europe won't work because the plugs are different. You'll either need a converter to be able to plug in the lamp, or you'll need an entirely new lamp from the US designed for a US plug. Software applications can do a lot of different things. Your web browser lets you jump around the internet to different servers and access websites that those servers serve up. You may have social media applications like Facebook, Instagram, Snapchat, or TikTok, which let you access specific websites and share things like photos and comments. You may have messaging applications, which let you talk to people directly via messages. You may have applications that let you play games, watch movies and TV shows, make video calls, check the weather, learn new languages, and so on. Applications can be written to do one thing or many things. We skipped over hardware and jumped straight to software because that's my area of expertise, but also because most of what you do on a computer involves software. The problem is that because users can't touch or feel software, it's a little bit harder to understand what that software is doing. I brushed off operating systems earlier as being useless without applications, which is true for the end user. However, operating systems do a lot under the hood. Just like the house contains complex unseen networks of electrical wires and plumbing pipes that provide utilities to the residents, operating systems run hundreds of processes performing unseen tasks, which allow the computer to keep working. If you don't believe me, grab your computer and open up Task Manager on Windows or Activity Monitor on macOS and check out all the processes running. It's not a small number. Additionally, if you own a smartphone or tablet, you likely have a number of different applications installed. Like operating systems, applications may do a number of things under the hood that the end user can't see. The problem is that nowadays, really anyone can write an application, and users have to trust that the application is doing what it says it's doing, and isn't off mining Bitcoin in the process, for example. Operating systems and app stores have started to implement safeguards against this. For example, your apps may have to now request permission to access things like your camera and your microphone, but the risk still remains. Your computer may do a lot more than you think it does, which can make it less safe for you. Alright, I think that's enough info for one episode. If you're interested in a little homework, though, consider taking a walk around your home or place of work. Try to pick out every single computer you can find, whether it's a big desktop computer or an itty-bitty little embedded system. Maybe it's less than you expected. Maybe it's more. Think on that, and I'll see you next time.
Hey, thanks for listening. If you want to keep up with the show, you can subscribe to our bi-weekly uploads on your favorite podcast feed or on YouTube at youtube.com/trialbywireshow. You can also find us on X, formerly known as Twitter, or Instagram at trialbywireshow, or on Facebook at facebook.com/trialbywirepodcast. If you have comments or questions, I'd love to hear them. Send me an email at trialbywireshow@gmail.com. See you soon.